Now let me solve problem number 1.248 for you. There is a figure given. Let me draw this figure first. There is a cylinder kept like this. This is a wall and this is horizontal ground. Now, let me read the problem statement. A uniform cylinder of radius r is spun about its axis to the angular velocity omega naught. It's spun about its axis to the and then placed into the corner as shown in figure. The coefficient of friction between the corner and the wall is wall of the cylinder is equal to K. How many turns will cylinder accomplish before it stops? Now, observe this problem and the situation. There is a vertical wall, a horizontal wall, so it form a corner, and at this corner we keep a cylinder. This is a cylinder, and the cylinder is initially rotated with some angular velocity omega naught like this, and with that initial velocity it's kept at this corner. Now, due to friction, this cylinder would ultimately stops. Before it stops, how many turn would it execute? कितने टर्न करेगा रुकने से पहले ultimately? Now, we wish to solve this. Now, this problem involves the brilliant ड्राइंग ऑफ द फ्री बॉडी डायग्राम. देखिए कौन कौन सी फोर्सेस लगेगी और कौन सा टॉर्क मिलेगा और किस टॉर्क की वजह से किस तरह से यह सिलेंडर रुकेगा. सबसे पहले मैं फोर्सेस, एक्सटर्नल फोर्सेस इंडिकेट करता हूं. mg इस सिलेंडर पर ग्रेविटेशनल फोर्स डाउनवर्ड डायरेक्शन में लगना ही है. मैं सबसे पहले उसे इंडिकेट कर देता हूं. जब यह हॉरिजॉन्टल सरफेस पर रखा हुआ है तो हॉरिजॉन्टल सरफेस के द्वारा कुछ नॉर्मल रिएक्शन भी इस सिलेंडर को मिलेगा. देयर वुड बी सम नॉर्मल रिएक्शन ऑफर्ड बाय द हॉरिजॉन्टल सरफेस, एंड this horizontal surface, there is a relative motion of the cylinder in this direction, and hence this horizontal surface would offer a frictional force. It would oppose the relative motion, hence the frictional force at this horizontal surface would act in this direction. This would be the direction of frictional force Fr, and for this frictional force I will immediately write that this Fr would be equal to mu into n always. Then when frictional force Fr act in this direction, observe that the cylinder could not move in this direction because there is a vertical wall. So this vertical wall would definitely offer a normal reaction in this direction. This wall would offer normal reaction n dash in this direction, and due to this normal reaction, now against this wall there is a relative motion of the cylinder in this direction, so this wall would also offer frictional force in this direction, Fr dash, and this Fr dash would be equal to mu into n dash. Also, I will say in horizontal direction there are only two forces. Now, are there any other force beside this? No, no other forces. No other forces beside this. mg, normal reaction. Due to this relative motion, frictional force here, and since there is a force here, equal and opposite force must be there. So n dash must be equal to frictional force. N dash must be equal to frictional force, and since there is relative motion in this direction, hence frictional force in this direction. And for mu, I should write K, because coefficient of friction they had wrote it equal to K. Mu is generalized term, but here in this problem, they had mentioned that coefficient of friction is K. Now, see this. After writing this, I will say in vertical direction one can always write normal reaction is equal to mg minus fr dash. Normal reaction is equal to mg minus fr dash. And for fr dash, I can always write, since this fr dash is equal to k n dash, k n dash, and for n dash I can always write k into fr, since n dash equal to fr, and for fr I can always write k into n, and hence this equation would finally look like this: n plus 1 n plus k square n is equal to mg, or n is equal to mg upon 1 plus k square. First of all, we conclude the value of normal reaction, and from this normal reaction, after concluding the value of normal reaction by this surface mg upon 1 plus k square, I can write the frictional force acting there. Frictional force is k into n, or k into mg by 1 plus k square. This is the frictional force acting there, and this is equal to normal reaction n dash. So I can also write this n dash is equal to k into mg by 1 plus k square, and for fr dash I can write k into n dash, or k square mg by 1 plus k square. This is fr dash. Now, हमने नॉर्मल रिएक्शन n, नॉर्मल रिएक्शन n डैश, fr और fr डैश सब कुछ निकाल लिया, सारी फोर्सेस की वैल्यूज हमें दिख रही हैं बिल्कुल mg और k के टर्म्स में. Now we'll determine the decelerating torque. Since it's moving in this direction, there would be a decelerating torque. Let's calculate decelerating torque. That decelerating torque would be mg would not provide any torque, n or n dash would not provide any torque. The torque would be due to fr and fr dash. Fr into r plus fr dash into r. This is the decelerating torque. Or this decelerating torque would be k plus k square into mgr upon 1 plus k square. This is the decelerating torque. This decelerating torque is equal to I alpha. I is half mr square into alpha. I would equate it in order to get the value of alpha. Half mr square alpha is equal to k into 1 plus k into mgr by 1 plus k square. This m would get cancelled, r would get cancelled, and I'll get alpha decelerating angular deceleration is 2k into 1 plus k upon 1 plus k square into g by r. This is angular deceleration. This is angular deceleration. Now I will apply, in order to get the number of turns, I will finally apply this equation, omega square equal to omega naught square plus 2 alpha into theta. So 0 is equal to omega naught square into 2. For alpha I will write minus 2k into 1 plus k by 1 plus k square into g by r into theta. So theta comes out to be this angular displacement before it stops, and this comes out to be 1 plus k square into r into omega naught square upon 4 k into 1 plus k into g. And for number of turns, I will say theta upon 2 pi. And this gives us 1 plus k square into omega naught square r upon 8 pi k into 1 plus k by g. This is the desired answer. This is the number of turns before it stops. बड़े ध्यान से देख लीजिए. Look at the complete solution. Mg, normal reaction, and due to that normal reaction there is a frictional force, and due to that frictional force there is normal reaction N dash here, and due to this normal reaction N dash, frictional force Fr here. This Fr equal to k into normal reaction, Fr dash equal to k into N dash, N dash equal to Fr. N is equal to mg minus Fr dash, N equal to mg minus Fr dash की जगह k N dash लिख दिया, N dash की जगह Fr because N dash equal to Fr. Then N equal to mg minus k, Fr की जगह k into N. So this becomes k square N, और यह k square N इधर चला गया, N plus k square N equal to mg. So N equal to mg upon 1 plus k square. Fr equal to kn, and hence N dash equal to Fr. This N dash equal to Fr dash, hence kmg. Fr dash equal to k into N dash. This is k into N dash. यह चीज कर दी मैंने, और फिर डिसीलेटिंग टॉर्क के लिए एक्सप्रेशन लिख दिया, and then I got the torque, I got angular deceleration. That angular deceleration we got angular displacement. Please note it down. I'll solve problem number 1.246 for you. There is a problem, there is a figure associated with the problem, and let me draw this figure first. इस तरह से एक फिगर दिया हुआ है, rope 1, this is mass m1 and this is mass m2 and this small m. The arrangement shown in figure, the mass of uniform cylinder of radius r is equal to m, mass of two bodies are equal to m1 and m2, the thread is slipping and the friction in the axle of cylinder are supposed to be absent. Find the angular acceleration of the cylinder and the ratio of tension T1 and T2 in vertical sections of the thread in the process of motion. Now this simple problem in fact. Let me draw the free body diagrams. हम तीन फ्री बॉडी डायग्राम बनाएंगे इस सिचुएशन के लिए. एक फ्री बॉडी डायग्राम तो यह जो सिलेंडर है इसके लिए होगी. अनदर फ्री बॉडी डायग्राम वुड बी फॉर दिस मास m1 and another free body diagram would be for this mass m2. Now what I will say is मास m1 से m2 में से कोई एक ज्यादा होगा. मास m1 पर m1g and here tension T1. So here tension T1, here m2g and tension T2. So here tension T2. If mass m1 is accelerated in downward direction with acceleration a, in that case this acceleration a would be in upward direction. This cylinder, there would be angular acceleration alpha. This is mass m. Now I will write a is equal to alpha into r, or alpha is equal to a by r. First of all, this thing, since there is no slipping. Now I will write equation for this. T1r minus T2r. This is accelerating torque. Torque due to T1 is T1r. Decelerating torque due to T2 is T2r. So T1 minus T2r, or T1 minus T2 into r for I half m r square and for alpha a by r. And this equation would reduce to T1 minus T2 is equal to half ma. This is for the cylinder. Now I will write equation for this. m1g minus T1 is equal to m1a, and for this T2 minus m2g is equal to m2a. I will add these three equations. मैं इन तीनों इक्वेशन को ऐड कर दूंगा, and I will get m1 minus m2g is equal to m1 plus m by 2 plus m2 into a, and this would give me the acceleration of the system, which is mod of m1 minus m2 लिखना होगा मुझको, क्योंकि अगर मैंने m1 को ग्रेटर मान लिया है, हो सकता है m1 कम हो, तो अपोजिट डायरेक्शन में होगा, एंड अपॉन m1 plus m by 2 plus m2. This is the acceleration of the system, constant acceleration. This would be constant acceleration. Then they ask the ratio of the tensions. हम कहेंगे टेंशन T1 इज इक्वल टू M1G माइनस M1A और M1 इंटू G माइनस A and tension T2 is equal to M2G plus M2A or M2 into G plus A. Tension T1 upon T2 would be M1 into G minus A upon M2 into G plus A. And I'll substitute the values. M1 into G minus, for A I'll write M1 minus M2 upon M1 plus M2 plus M by 2 into G, and here M2 into G plus, for acceleration, M1 minus M2 upon M1 plus M2 plus M by 2 into G. One can always solve it to get the answer. T1 upon T2 would be M1 upon M2 into M plus 4M2 upon M plus 4M1, it seems. 4M. This would be the answer. Please solve it and check it. सिर्फ यहाँ 3 फ्री बॉडी डायग्राम बना लेना है, डिस्क सिलेंडर के लिए, 2 ब्लॉक्स के लिए, और उनके लिए इक्वेशन लिख देना है. प्लीज सी द सॉल्यूशन. प्लीज चेक इट.